Okay, so today we are going to be walking through how to deal with equations that use absolute values. So, what are absolute values? Absolute values are basically just two vertical bars that go alongside a number or a expression, something like, let's say, maybe a. This would be the absolute value of a. Now, what that means is if a is less than 0, then the absolute value of a, let me rewrite that. The absolute value of a equals negative a. So let's work through a few examples where a is less than 0. So if a equals negative 2, the absolute value of negative 2 is negative 2. And so that is to say, our negatives cancel. Really, it depends on how you want to write this out. I think it might be a bit more reasonable to have it negative 1 times a, but really we have double negatives, and so it's reasonable that this will be just get 2. This might not be the most rigorous way of expressing it, but I think it makes sense. So if we have negative 3, absolute value of negative 3, negative 3, and again, double negatives, they'll cancel, give us 3. So negative 117, that will be, we want the absolute value, that will give us negative 117, that will give us 117. So here we have the absolute value of negative values. We just basically propagate through a negative sign, and the negatives cancel and give us a positive value. So that's what we do when a is less than 0. What about when a is greater than or equal to 0? For those cases, the absolute value of a equals just a. So the absolute value of 0 is 0. The absolute, not that. The absolute value of 5 is 5. And so, really, the way that we can look at this is if we have the absolute value of a, that will be just equal to a, where this value here will always be positive. It will be, no matter what a sign is, it will be a positive a. So, if you think about it, the absolute value bar is kind of just telling us to get rid of any negative value. So if a is negative, we just make it positive a. So let's see. Let's get into solving some problems, because I think that really explains what's going on much better. So if I were to ask you to solve this equation, let's see, or not equation, if I were just to ask you to give me the value of this, provided m equals negative 5. How do we go about getting the value for this? Well, we would start out, plug in negative 5 for our m, and so we are left with this. So negative 5 plus 3 minus 14. Let's first evaluate what's inside of the absolute value brackets. So negative 5 plus 3 is negative 2 minus 14. The absolute value of negative 2, well, we just make it positive. And then we subtract the 14, which gives us at the end negative 12. So this kind of approach where we're given a value that uses variables, and we are given the value for the variables, and we are asked to find what the number value for this expression is. This is something that we'll see quite a bit. So let's work through one more example. H plus 4h absolute values minus 10h. And let's make h equal 3. So all we do is we take this expression, we plug in a 3 for every point, where we plug in 3 for all of the h's, so we get 3 plus 4 times 3 minus 10 times 3. So something important, we can kind of see it right here. Make sure you don't make these vertical bars become 1s, because it would be very easy to take this and then go through and solve it. Well, 13 plus 4 times 31, that'd be 4 times 12 minus, let me make sure I did that right, yeah, minus 10 times, so 30, so 13 plus 124, that'd be 137 minus 30, so I get to 107. So tragically enough, even though I made no mathematical errors, really, I didn't add wrong, subtract wrong, anything like that, this answer is completely wrong. And the reason being is I accidentally just let this bar kind of start to look too much like a 1. So pay very close attention to these to make sure that that doesn't happen. I would always do something like maybe using these parentheses to prevent these from getting too close and then becoming part of your number. So with that being said, let's continue not worrying about that. Just keep an eye on it, because I can already tell that that's going to be something that will trip some people up. It would trip me up. So let's see. And we'll throw in our little parentheses. Minus 10 times 3. Okay, so, and the other thing is going this way seems like it's going to be a lot easier. So 4 times 3, that would give us 12, plus 3, that's going to be 15, so we get absolute value of 15. And the other thing you can do is you can make these just massive in comparison to your numbers. That should also kind of keep things where they should be. Minus 30, so absolute value of 15 is going to just be 15 minus 30, and so we're left with negative 15. I think it's also kind of important to note that even though we're working through with absolute values, our final value was negative. There's nothing wrong with that. The only time that you run into an issue is if this entire thing was in absolute values and we got a negative. Just kind of make sure that at every step you know what you're doing. If at every step you're doing the right thing, then if you get to an answer, it will be right. And that's important, because sometimes you get to an answer and you made a mistake somewhere, like here, and you're wrong. And you're not only kind of wrong, but you had 107, and the right answer is negative 15. That's pretty wrong. So really make sure that you're going through each step carefully, because if you go through each step carefully, when you get to the final value, you can be confident that that is correct. So, with that being said, what else do absolute values, what else can we do with them? How else will they appear? So let's think about that. So what if we are given an actual equation now, where we have something like g plus 10 minus 2 equals 4. So how do we go about solving this? Well, the thing is when we have these absolute value bars, there will be two different cases we need to consider for whatever's inside of these absolute value bars. So I'll throw these to be safe. What if g plus 10 is positive? So we need to work through for that case. So let's say case 1, g plus 10 is greater than or equal to 0. So one thing, I say positive, really should have just said greater than or equal to 0. That's more clear. Positive doesn't really capture 0 like we want it to. So we're working through when g plus 10 is greater than or equal to 0. And so what that means is if g plus 10 is greater than or equal to 0, the absolute value of g plus 10, what would that be equal to? Well, it will just be g plus 10. Remember, because if you have the absolute value of a, where a is greater than or equal to 0, this absolute value of a is just going to equal a. So that same approach works here. And what that means is now, in this case, where g plus 10 is greater than or equal to 0, we can just replace our absolute values of g plus 10 with just g plus 10. So g plus 10 minus 2 equals 4. Now we do our 3 steps for solving any equation or any multi-step equation. Step 1, simplify. G plus 10 minus 2, so g plus 8 equals 4. Step 2, isolate your variables on one side. So we will use the subtraction property of equivalence to write this as g, then subtract 8 from both sides. So equals, let's see, minus 8, minus 8. 4 minus 8, that would be negative 4. And we don't even need to use our final step. We're good. We have g equals negative 4. So we're good. But have we solved every possible instance of this equation? Have we solved for every possible value of g? And the answer to that would be no. So let's see here. G plus absolute value, g plus 10 minus 2 equals 4. So let me make 100% sure I got that right. Minus 2 equals 4. Okay, just wanted to be 100% sure. And then I think our first value of g was negative 4. And how I would designate that, just do g, and just give it something to show that this was the case where we assumed that g plus 10 was greater than or equal to 0. I know that we are not really supposed to say that's the positive case, but just for note keeping, I think it's fine, just so that we can know that one of the values for g is negative 4. Okay, so we're going to look for the other case. What is the other case? Well, that's going to be the case that g plus 10 is less than 0. So if g plus 10 is less than 0, so this would be case 2, then what would the absolute value of g plus 10, what would that be? Well, if you remember, the absolute value of a, where a is less than 0, the absolute value of a equals negative a. So, same property applies here. The absolute value of g plus 10 when g plus 10 is less than 0 is just going to be negative g plus 10. And remember those parentheses. So, we can plug this through our original equation, and we get negative g plus 10, always remember the parentheses, minus 2 equals 4. So now we just distribute our negative symbol, negative g minus 10 minus 2 equals 4. We're now doing step 1 of our solving equations. We're just simplifying everything out. So negative g minus 12 equals 4. Step 1 complete. Step 2, we want to isolate our variable, and so we add 12 to both sides. We get negative g. So we added 12 here, added 12 here, and so what we end up getting is this equals 16. Now we have to do our third step here. This time it's not too hard. We can either multiply by or divide by negative 1. I'm going to multiply by negative 1. So negative 1, negative 1, negative 1 times negative g would just give us g equals negative 16. So let's see here for a second. Okay, so g for the negative case is going to be negative 16. And to express this out, let's invoke our solution set. So our solution set is just going to be the set with the solutions, and that will be negative 4 and negative 16. So with that being said, let's check ourselves. So if we plug in negative 4 to this, let's see what we get. Well, negative 4 plus 10 is 6, so we have absolute value of 6 minus 2 equals 4. So that would be 6 minus 2 equals 4. Excellent. So this is good. This is a true statement. Our equation is good. Negative 4 works. Let's try negative 16. And so for that, negative 16 plus 10, that will give us negative 16 plus 10, 10 minus 6, negative 6. Minus 2 equals 4. Absolute value of negative 6. 6 minus 2 equals 4. Great. We got both of the possible solutions right. So this is our solution. These are this is the solution set for g, the possible values for g for this equation. So you can see here these equations require a little bit more time because we have to work through both cases. So that's important. One thing to keep in mind is going through both cases is only required if your variable appears in your absolute value bars. So if I say something like g plus absolute value of 2 minus 5 equals 7. And let's just throw a 2 in front of our g for good measure. So if I were to solve this equation, there's only one case, there's only one possible value for g, because no matter what, the value of this absolute value bar, or the absolute value here, is just going to be 2 minus 5, negative 3. It's just going to be 3. So we would solve this. 2 times g plus 3 equals 7. We would really solve this like a regular equation. This is the first part of our step 1. We're just simplifying. So we've simplified the equation. Now we isolate our variable using the subtraction property, subtracting 3 from both sides. And so we get 2g equals 4. Now we move on to our final step where we use division this time to just get g equals 2. So there's only one solution for g in this case. And that was because g fell outside of the absolute value bars. So you only will have to resort to cases if your variable falls inside the absolute value bars. What about if we have a case where let's use h plus the absolute value of 3h minus 2 equals 7. What if we have where a value falls outside of the absolute value bars and a value falls inside. Well, this isn't going to be anything different than the first thing we solved, the time when we had to use our cases. Since we have and I'll throw my parentheses, since we have a value inside of our absolute value bars, we consider two cases. Case 1, h is greater than or equal to 0, and for that we just say h plus absolute value, or actually we can get rid of the absolute value from the get-go, 3h minus 2 equals 7. And the reason we are able to just drop the absolute value bars is because h is greater than or equal to 0. That means absolute value of 3h minus 2 is equal to 3h minus 2. So we are able to just get rid of those. And now we can solve this like we'd solve any equation. Step 1, we simplify, so we get 4h minus 2 equals 7. Step 2, we isolate our variable, so we add 2 to both sides to get 4h equals 9. And step 3, we use the division property to get our h, and h would just be 9 over 4, and that would be the same as 2 and 1/4. So this will give us our h when h is greater than or equal to 0. And so I'm going to use the following notation. I'm going to say h equals then this set. I'm not 100% sure if this is exactly how they'd like you to have it. And so this would be acceptable for me. I would get what you were showing me if you just have h equals and then the two values for your solution set. If you wanted to be extra rigorous and give it to me as probably the proper way, I would say something like solution set of h equals or s sub h equals. But kind of shorthand for writing out all of that, I'll accept this h equals. If it starts to be an issue, we'll have to go back and kind of make sure everyone understands that h isn't a set, it's the values in the set. But I think for shorthand, this might work. So I think that's acceptable. So let's see. Actually, I think I'm going to write this out as 9 over 4, just to make sure. So let's see. What's the other possible value for h? Well, for that, we just assume that... oh, really quick, my apologies. I realized my case was wrong. This wouldn't be that h is greater than or equal to 0. This would be that 3h minus 2 greater than or equal to 0. Doesn't change my work, but that would be that I would have lost a few points on that. So make sure that you set it as whatever's inside of your absolute values. With that being said, to find the other possible value for h in my solution set, all I do is I take my case 2 and say 3h minus 2 is less than 0. So for that, all I would do here is, instead of just replacing this with 3h minus 2, I would replace this with negative 3h minus 2. And so I'd get h minus 3h minus 2 equals 7. So now all I would need to do is simplify. So h minus 3h plus 2 equals 7, and then I could write this as negative 2h plus 2 equals 7, and then I would isolate my variable, so subtract 2 from both sides. I'd get negative 2h equals 5, and then lastly I would use division to find my value, and I would get h equals negative 5 over 2, so negative 5 over 2. And I'm fine with this being in improper fraction terms. sometimes improper fractions are a bit more helpful. In this case, I'm kind of using them for clarity. I think it's a bit more clear, not having the 2's kind of floating around and stuff like that. So this would be our solution set. And I'm really squeamish about letting this say h. I do think that it might be helpful, and I do think I'm going to go back on that. I think we might just want to call it something like s sub h, just knowing that this is the possible values for h. So let's go with that for our notation. We'll use s sub h to say the solution set of h. But really, rarely will you even need to tell me this. If you just show me the set, we'll be fine. So let's plug through and check really quick. So let's see. Let's try 9/4. 9/4 plus absolute value of 3 times 9/4 minus 2. Absolute value bar equals 7. And so what is 3 times 9? That's 27. Oh, this is going to be a bit more, take a bit more space than I thought it would. So let's see. 3 times 9, 27 divided by 4. Oh, 6 1/4. Minus 2 equals 7. Let's see. This would be 2 1/4 plus 6 1/4 minus 2. Something's gone wrong here. Let's see. Let's just go. So if I take, I'm just going to put the time into working through it fresh. So let me erase all of this, because I think maybe if we go through it a bit slower, I won't make a silly mistake. So let's see. H plus, or actually we have that already. So 9/4 plus the absolute value of 3 times 9/4 minus 2. Okay, equals 7. So let's see. Now, if we have, let's convert 9/4 to a mixed number, and so that would be 2 1/4 plus 3, absolute value of 3 times 2 1/4 minus 2 equals 7. So 2 1/4 plus, so that'd be 6 and 3/4, because we had to multiply 3 by both of those, minus 2 equals 7. 2 1/4 plus, so this would be 4 3/4 equals, oh joy, 7. Good. I was getting worried there for a second, because 2 plus 4 is 6. 1/4 plus 3/4 7. So good. Hopefully that all made sense. But really, you know, if you want to, you can take and go through the process a bit slower. I was just wanting to show that it's a good practice to check yourself. So that's right. Let's hope this other one goes a bit smoother. Let's see. Let me bring out this. Okay, so negative 5 over 2 plus absolute value of 3 times negative 5 over 2 minus 2 equals 7. And here, let's just keep it as an improper fraction. Negative 5 over 2 plus negative, or the absolute value of negative 15 over 2 minus 4 over 2 equals 7. Keeping everything good. Okay. Negative 5 over 2 plus, let's see here. So this would be negative 19 over 2 equals 7. Now, I know this is going to be negative. I don't even need to evaluate it to just look at this and say it's going to be a negative number. So before I even evaluate it, I can get rid of those absolute value bars, and I'm left with 19 over 2. And so finally, 19 minus 5 is 14. So I get, yay, 14 over 2 equals 7. We're good. So there we go. That time the checking was a bit harder than solving it, I think. With that being said, I guess the last thing to look at is what about plotting the solutions? So if I have a, let's see, kind of a graph for this one, I'll have the positive values, so, or let's see, we'll go from positive to negative, so, and I'll have negative 3, negative 2, negative 1, 0, 1, 2, and then 3. So first point, 9 over 4, that fall about right there. Second point, negative 5 over 2, so that would fall about here. And so this would be the plot. We'd have a point at negative 5 over 2 and a point at 9/4. Typically, I'd say labeling these is nice, especially if, you know, like me, and you're a little bit sloppy when you write it out, just so I know where you were trying to say it would go. So, good. I guess the last thing that we are going to talk about for this is what about absolute value equations where we have kind of unique equation or unique situations rising up. So let's see. Let's consider the case where absolute value of 3n minus 4 equals negative 1. So consider the case where, so case 1, 3n minus 4 is greater than or equal to 0, and so we get 3n minus 4 equals negative 1. We add 4 to both sides to isolate our variable, so we get 3n equals 3, and then let's see, we get n equals 1. Give me just 1 second, let's see. So, something went wrong, I think. So obviously this is not going to be valid, but I'm trying to see exactly why it follows directly from the math. Um, so let's see. I think the problem is, and I'll come back and make a correction video if it works out to be something different. Um, I think the issue is so we find that n equals 1 for this, but the problem is if n equals 1, then our case is wrong, right? Because we say that this is a case where 3n minus 4 is greater than or equal to 0. But the problem is if n equals 1, then this is negative 1. So n equals 1 is the only possible solution, and it can't be the solution because it would go against what we assumed in this case. Okay, so that was a little bit weird. I'm thinking that's the approach that we needed to take. If I realize that I made a mistake on this, I'll come back and make another video explaining the right way. But I think that's kind of what we should end up getting and why. That we would solve this through, get n equals 1, and then we would simply just need to realize that it would invalidate our case, and so it's not a viable solution. Or we could always say n equals 1, plug it through here, and we would get 1 equals negative 1, so we'd find out that n wasn't a valid solution. So that would be how I think I would rationalize n equals 1 not being a valid solution. With that being said, I will upload another video if I find a better explanation. But let's move on to our case 2. And so for case 2, if we assume 3n minus 4 is less than 0, what happens? So we make our 3n minus 4, we make it negative, so we get negative 3n plus 4, if we just propagate the negative through from the get-go, equals negative 1. So now we take and subtract 4 from both sides, so we get 3n equals negative 5. Now we divide both sides by negative 3, and so we get n equals 5 thirds. Negatives will cancel when we divide. And so let's see with this, if we take and plug this n back into our case, we get 5 thirds times 3, that would be 5, minus 4, that's 1. 1 is not less than 0. So, we can't use this n since it goes against the case that we had. So this n is also not acceptable. With that being said, this is showing a case where, or a example where there are no solutions, and really it's kind of easier to look at this one and see there's not going to be any solutions, because you'll never have the absolute value be a negative number. But I kind of just wanted to work through a slightly more involved question where we had no solutions, and I think the approach that you would take is whenever you find this, you would just make sure that your the variable will agree with the case that you've assumed, and if it does, you're good. You can throw it in your solution set. If it doesn't, then that's a problem, and you can't use that variable in your solution set. Hopefully that makes sense. I know we got a little, I got a little twisted around there for a bit. So if you have any questions, please ask. I guess the last thing that I will kind of talk about for just a second is occasionally we will have where there is a variable inside of the equation, or inside of the absolute value brackets. And I'm just going to give a simple case just to keep your mind open to this. If I have something like the absolute value of h equals 0. Now, the answer to this is pretty obvious. H is going to be 0. But I think it's important to kind of walk through, consider the cases, and see what happens. So for something like this, we would take case 1. We assume h is greater than or equal to 0. And so what would we get? We would get h equals 0, because we can just let this absolute value of h equal h. So when h is greater than or equal to 0, h is 0. Case 2, h is less than 0. So we would say negative h equals 0. And so what we would find here is h equals 0, but we would actually throw out this solution because we just assumed that h was less than 0. So when we found h equals 0, goes against our case, we throw it out. So for this, we have an absolute value where there's only one solution. So it's important to kind of remember that sometimes there'll be one solution, sometimes there'll be no solutions, and kind of keep in mind that if your final value, the value you show for your variable, goes against the assumption you made in your case, then you can't use it. It doesn't get to go in your solution set. Hopefully that made sense. If anyone has any questions, especially on that last part, because that last part did get a little weird, please just let me know. Thank you very much for watching. I know this video was a little longer than normal, so thank you for bearing through it with me. Hope you have a nice day.